Hello, good morning everyone. So this will be my first video on my channel. My name is Priyanka S Walko and I'm a researcher. So today we'll discuss some introduction. So what in this channel what we will talk is basically H2 H2 evolution. Okay, just don't mind my this thing. So we'll talk about H2 evolution. From where this we'll get it from this H2O. Okay, so this is what we'll talk, and today we'll start with introduction. So before we go into this, we should know the energy facts. So fossil fuels are depleting at a rate that is 100 times faster than they are formed, right? And if we see on an average, 16 billion tons of CO2 is emitted into the atmosphere every 24 hours by human use worldwide. Okay, and this coal is the biggest air polluter, and burning coal causes smog, acid rain, global warming, and toxic air emission. If we see, this environmental pollution leads to many kind of things, right? Everything like acid rains and all. And if we see, this is the long term emergency. What happens? This depletion of fossil fuels leads to economic instability, and due to this climate change will happen, and this is the long term emergency, right? And then and we are showing the transition to hydrogen energy. How we are showing is that in present scenario, if we see here, we are using petrol diesels but for power generation. But what is happening, this petrol diesel leads to carbon containing emission, right? So which leads to pollution and which are not good. Then we have moved on to this intermediate stage, that is electric hybrid vehicles, but cost of these are very costly spare parts, and because of that we have to think about the ultimate source, that is this environmental friendly and carbon free hydrogen based vehicles for power generation. ठीक है, if we consider this solar energy, the amount of energy which has been released from this solar light is 1,73,000 terawatt, and whatever amount we are using out of this is very less compared to what we get from this single source. Okay, so it's better to use this thing, because if we consider our area, we get more amount of sunlight than compared to other things, and it is better to utilize this sunlight, right? So why we need this hydrogen stores 2.8 times more energy. If we see this hydrogen, it stores 2.8 times more energy than that of the gasoline, and this effective storage of hydrogen is one of the key elements of hydrogen. This effective storage of hydrogen is one of the key elements of hydrogen economy, and hydrogen is an energy carrier, and it also cleans and long-term energy source, and because of that this is very useful. Okay, and then one question comes like, how can we get this hydrogen, right? If we see the reaction, that is, if we mix 2 moles of hydrogen, this 2 moles of hydrogen and 2 moles of oxygen, we get 2 moles of water molecules, and lot of energy will be released, right? And if we reverse this reaction, what will happen? This 2 moles of water and energy will get 2 moles of hydrogen and water, but the amount of energy which is required is very high. And what we can use some kind of catalyst to reduce this energy, and what will happen, we'll split this water into hydrogen and oxygen, and we'll get catalyst will be regenerate, right? So then question comes, does this catalyst really exist? So if we look into the nature, this photosynthesis phenomena, what plant do is that a plant utilize carbon dioxide and water to produce their food, and oxygen, and the amount, and they utilize light source of sunlight as a energy source, and this is the reaction which they. So what scientists have done is that they have mimic this process by using water molecule and some kind of powdered material, and they have split this water into hydrogen and oxygen, and then this is called the artificial photosynthesis. Okay, so and then things comes like from where exactly the origin of photocatalysis comes. If we see this Kenichi Honda and Akira Fujishima in this year 1972, what they did is that they have taken this electrochemical setup. In one case, in that setup, they have put this TiO2 electrode and platinum as a counter electrode, and in that they have coated this platinum over this electrode and TiO2 electrode, and they have irradiated with this UV light, and what they could found is that whatever electrons are there, no, these electrons are moving here, and what is happening, these electrons are moving from this bias to the counter electrode, and hydrogen is producing, and we are getting the hydrogen produced. So then they have explained the mechanism. If we consider this TiO2, what is happening in presence of light, these holes and electrons are created. Okay, and half oxidation is happening, and due to this we are getting this 2H plus and half of O2, and reduction of this 2H plus by using electrons we are getting hydrogen, and the overall reaction is from water molecule in presence of light and this semiconductor material we are getting this hydrogen and half of O2. Okay, so then after doing this we should know the basic of water splitting basically. So if we see, this is the beaker. In that beaker we have powdered material and water, and this is the sunlight, and we are getting hydrogen and oxygen, and this particular particle shows the lot of processes like step 1, step 2, step 3, different processes are there, and in that, see, can you see this particular one particle is showing this process. So for there are different steps like absorption. First what will happen, these particles will absorb the sunlight, right? And after, what will happen, electrons and these holes and electrons will be generated, and after that this charge separation will happen to the surface, and electrons and holes will migrate to the surface of this semiconductor, and will get the respective oxidation and reduction processes, right? But these things need to have, these semiconductor material need to have some kind of what we call condition, right? So we will not get any kind of things until unless the band gaps of this material matches with the redox potential of water. That is, conduction band of this material should be more positive than that of the hydrogen redox potential, and it should be more negative than that of the oxidation reduction potential of oxygen. Then only we can split this H2O into H2 plus half of O2. Okay, in this way we'll get the things. Now, after that, we have to think about the stoichiometry of hydrogen and oxygen evolution reaction. After thinking about the conditions, we should know the stoichiometry of hydrogen and oxygen evolution reaction. We know the overall reaction. If we take 2 moles of H2, we will get 2H2 and plus O2. That is the twice the amount of hydrogen molecules produced than that of the oxygen molecules. And produced hydrogen gas has twice the volume of produce oxygen gas. So then comes the role of sacrificial reagent. We use to test the hydrogen evolution reaction. We need the whole scavenger reducing agent which can scavenge these holes, and will get more amount of electron and will get more amount of hydrogen. And for if we want particular oxygen, we can use the oxidizing agent which can take up these electrons, and what will happen, will get more amount of holes and will get oxygen in the reaction. And sometimes we need to think of role of co-catalyst also, because sometimes surface recombination happen, and to reduce the surface recombination we need the co-catalyst, and basically co-catalyst of platinum, nickel and all people use. So by doing this, so till now we have, this is just the basic of overall things which are presented. So in next video we'll talk about more about the more deep into the reaction of the slides. Okay, thank you so much.